I'm Anil Kumar sharing with you part 1 of review on MCR3U functions as a prerequisite for advanced functions. We'll take a few questions based on quadratic functions and domain and range in this particular video. In next 3 or 4 parts, I'll cover up the other sections, basically trigonometry, exponential equations, and logarithmic equations, to complete the review. The questions here are: question number 1, 3 times a number taken away from its square is 378. Find the numbers. Question 2, find 3 consecutive even numbers such that the sum of the squares of the smallest integer and the product of the other 2 integers is 928. Question 3. Determine the nature of roots of each of the following: 3x squared plus 2x minus 4 equals to 0, x squared minus 5x plus 8 equals to 0. And question number 4 is: find domain and range of the following: f of x equals to 4 over x minus 2 plus 2, and g of x equals to 1 minus square root of 5 minus x. You can always copy these questions, try them out, and then look into my suggestions. So let's solve them one by one. Question number 1. 3 times a number taken away from its square is 378. Find the number. I changed the statement a bit since the original statement created some problems. So let the number be n. Let the number be n. Now let's write down the equation. 3 times a number taken away from square, from its square. That means n square. So n square minus 3n should be equal to 378. So that becomes the equation. 3 times a number, that is 3 times a number, taken away from its square, means n square, taken away, is equal to 378. Doesn't make sense, right? Now you need to find numbers. So it's a direct application of quadratic functions. Well, bring the terms together, we get n square minus 3n minus 378 equals to 0. Now you could use quadratic formula to factor or find the solution, or factor and find the solution. Now we are looking for 2 numbers whose product, let's say p and q, is minus 378. So you want 2 numbers whose product is minus 378 and whose sum is 3. That means they are very close, right? So they are very close. So whenever that is the situation, the hint is find square root of 378. Numbers close to this will be part of your solution. So we do square root of 378. So we get 19.4. So that means the numbers could be less than 19. So 18 could work. So we could have 18 as one of the numbers. Let us check. If I divide 378 by 18, what do I get? I get 21. So 18 and 21 could work. Since we are looking for product is negative and sum is also negative, so that means bigger number is negative. We get negative 21 and positive 18. That should work. So now I could write down my quadratic equation factored form as n minus 21 times n plus 18 equals to 0. Now that gives us 2 solutions, n equals to 21 and n equals to minus 18. So these are the solutions for the given question. It is always a good idea to check your solution, right? So let's check this. So in the calculator, let us substitute 21 square minus 3 times 21, which is 378. And let's do with minus 18 also. So within brackets, minus 18 square minus 3 times within brackets minus 18, right? And that gives you 378. So both work, right? So when you check, both of them work, and therefore we can write down the answer as the numbers could be minus 18 and 21, right? So let's move on. Take question number 2. Find 3 consecutive even numbers such that the sum of squares of the smallest integer and the product of the other 2 integers is 928. So consecutive even integers. So if I take n as one of my numbers, then even numbers will be n plus 2, n plus 4 and so on. But it's a good idea to take n as 1 and n minus 2 and n plus 2 as the other 2 integers. So when working with 3 integers, I'll prefer to define like this. This results into simpler equations, right? So that is very important note. So that is how we are going to define. So I would like you to note this, right? We'll learn factoring strategies also in this particular video. Now let's write the equation. So that is a let statement. So let the numbers be as shown here. Now it says, find 3 consecutive even numbers such that sum of the squares of smallest integer, that means we have to add square of the smallest integer, and the product of other 2, means product of these 2, which means n times n plus 2, is equal to 928. Do you understand the equation? That is how we have to get the equation. This is the most critical part of the question. Now, let us expand and simplify. N minus 2 whole square can be written as n square minus 4n plus 4. Let's expand this. We get n square plus 2n. Bring 928 to left side. Minus 928 equals to 0. So as you can see, we have applied the formula here, which is a minus b whole square is equals to a square minus 2ab plus b square, correct? If this was positive, this is positive, correct? Okay, now combine the like terms. N square gives 2n square. Minus 4n plus 2n is minus 2n. Plus 4 minus 928 means minus 924 equals to 0. We can divide by 2, giving us n square minus n minus, dividing by 2. 2 times 4 is 8, then 6 and 2 equals to 0. Now we need to factor. We are looking for 2 numbers which are very close. So the strategy here is find square root of 462. The numbers will be approximately that, right? So very close to this. We're looking for 2 numbers, of course. Square root will give us 1 number, which is around our solution. Square root is 21.49. So as you could see, we could try the numbers like 21 and what? Ending with 2, that means 22, right? Let us check. So if I do 21 times 22, what do I get? 462, right? So this is a very effective way of factoring, especially when the coefficient of n or x is small. So what we get here is n minus bigger number, right? Times n plus 21 should be equal to 0, and that gives you n equals to 22 or n equals to minus 21, correct? So once you know n, you can write all the 3 numbers. So it says find 3 consecutive even numbers such that this sum, right? So if I use 22 as n. Then we have answer set 1 as 22. 2 more is 24 and 2 less is 20, correct? This is one combination. If I use the other set, which is minus 21, then what do we get? Minus 21, which is not even, right? So we are looking for even numbers, right? Minus 21 is not even, so it is not a part of solution. Does it make sense? So the only solution is the set with positive number 22. So I hope that makes sense, right? Let's move on and take up question number 3. Determine the nature of roots of the given quadratic equations 3x squared plus 2x minus 4, x squared minus 5x plus 8 equals to 0. Basically, if the equation is ax squared plus bx plus c equals to 0, we are looking for b squared minus 4ac. Now, if this term is less than 0, then we have imaginary roots. If b squared minus 4ac is greater than 0, then we have real roots. 2 of them, right? So 2 roots. And if b squared minus 4ac is equal to 0, we have 1 real root. Nature of root will be, this is quadratic. This one real root is quadratic, that means order 2. And those 2 real roots are linear. So that is what we are trying to figure out in the given question. So let's find b squared minus 4ac. So in this case, b is 2, so 2 squared minus 4 times a is 3 and c is minus 4. So we get 4. Minus and minus becomes positive, right? So we get 12 times 4 is 48, which is 52. Now since this is greater than 0, what do we have? We have 2 real linear roots. Is that clear? For the second one, b is minus 5, so b squared minus 4, a is 1, c is 8. So we get 25 minus 32. Now this is definitely less than 0, and therefore in this case we have imaginary conjugate roots. Correct? So that is how you can actually describe the nature of roots. The last question here is based on domain range. I would like you to pause the video, answer this question, and then look into my suggestions. We need to find domain range of the following. A, f of x equals to 4 over x minus 1 plus 2. And B is g of x equals to 1 minus square root of 5 minus x. The first one here, the denominator cannot be 0, right? So since x minus 1 cannot be equal to 0, we know x is not equal to 1. So that gives us a restriction in domain. So we can say domain x is x belongs to real numbers where x is not equal to 1, right? As far as range is concerned, here we have a horizontal asymptote at 2. Since this function cannot be 0, it approaches 0. So it will never be 2, right? So in this case, we have range as y belongs to real numbers so that y is not equal to 2, right? Now, this question at times could be extended, and you may be required to sketch. So you could actually make a rough sketch to justify your answer. This basically means vertical asymptote at 1, so which is right here. That means horizontal asymptote at 2, right? So this is at 2, this is at 1. Now, if I write x equals to 0, I get minus 4 plus 2, which is minus 2, right? So at x equals to 0, I am expecting minus 2. So there's some here. If I write y equals to 0, in that case, so we get 4 plus 2x minus 2 equals to 0. So that gives you 2x equals to minus 2, or x equals to minus 1 for y equals to 0. Is it okay? So the x-intercept is at minus 1. And that clearly indicates that your graph should be kind of like this. Is it okay? Right. Now, let's do part B. G of x equals to 1 minus square root of 5 minus x. You have to be very careful in doing this question. I will suggest rewrite your question. So think this is 1, right? So let me rewrite this as minus square root. Let's write x term first. Plus 1. This is a familiar way. You should factor out this negative 1. Then you get x minus 5 within square root plus 1. Now that helps you to really understand and sketch the function. So now let me sketch this function quickly. Normally the function square root x will be kind of like this. But in this case, we have two kinds of reflections. This one here means you will reflect it on the x-axis. This is minus square root x. Now this reflection is kind of like this. This is minus square root x, inside also minus. And that negative will take it 5 units to the right, and it will be kind of like this, where this point is 5. Now it becomes very clear how to write domain and range. So you can write domain is x belongs to real numbers, where x is less than equal to 5. Does make sense to you? And the range is y belongs to real number, where y is, now I forgot to do plus 1, so I have to take it up 1 unit. And let me draw the final structure. This one, right? So when you take this one, it has to move 1 unit up, and then it is kind of like this. So that is the final function as sketched, right? So you get range as y less than equals to plus 1, right? So this is 1 for you. So once you sketch, it is absolutely clear. So I hope that helps. We'll continue with this series. In part 2, 3, 4, and 5, we'll cover up trigonometric functions, exponential, logarithmic functions, and rational functions. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'll be great. Thanks for watching, and all the best.